Okay, this is the first lesson for the week of April 27th through May 1st. And this is now chapter 14. We're getting close to finishing up our material. And we'll be in the first two sections of chapter 14, 14.1 and 2. And what it'll be talking about is solutions. We've actually introduced solutions in the past. If you go way back, we had pure substances and we had mixtures. A pure substance means that we have a fixed ratio of elements. A mixture means that we have compounds or pure substances which are mixed together, but it could be in any ratio. So we've talked about this in the past. If I take water and I put a little bit of salt in it, I have pure water, pure salt, and I have a saltwater solution. If I add more salt, it's still a saltwater solution. It's now just has a different ratio between them. When we say homogeneous, it means that it is the same throughout, and that we would have, if you were to take a sample of the solution from one little piece or from another part of it, from, let's say you went out to your pool and you took a cup of water from one end of the pool and went down to the bottom, took a little sample from the bottom, another one from the deep end of the pool, they would all have exactly the same composition. And that's what a solution is. Now, there's many types of solutions. We can have a solid solution that's called an alloy. In fact, I think one of your questions in your homework asks about an alloy. An alloy is two solids, two metals that are mixed together. We can have a gas solution. Atmosphere is an example. We can have liquid solutions, and I'll demonstrate one of those here in a minute. We can have a solid liquid solution. In fact, you can have any of the phases. That's really not so important for what we're doing. For the most part today, we're going to be dealing with aqueous solutions, and that word aqueous means it's a water-based solution. And what I want to do is give you a number of definitions, because this is the introductory section, and talk a little bit about how things dissolve, which actually has a name. It's called solvation, not salvation, but solvation. So let's start with the definition of solution. A solution is a homogeneous mixture, which means that it is so mixed in a way that you cannot see the parts, and it's at least two things, and it can be mixed in any ratio. There are always two parts to a solution. There will be something called the solute and the solvent. Now, what's interesting is there are two different definitions for solute and solvent, and I'm going to give you both of them. I'm going to give you the first one right now. A solute is usually the part that dissolves, but that's for an ionic compound or an ionic solution. And the solvent is the part that does the dissolving. And once again, this would be for an ionic solution. So let me talk about ionic solution first. An ionic solution is one, and we're dealing with aqueous solutions. That's where we saw that little AQ. Aqueous means it's a water solution, and almost always the water will be the solvent. An ionic solution means that we have ionic compounds. We have an ionic compound dissolved in water. So we can make an ionic compound solution really simply. I have some water, and I have some salt, and I take and I put my salt in the water, stir it up, and we will have a saltwater solution. Now, we're going to talk in a second about how that salt dissolves, and it's actually relatively simple. In fact, let's do that right now. What's going to happen is this. If you remember, this represents salt, and these are water molecules. Salt, the blue is sodium, it's a positive. The chlorine is negative. And this is the negative end of a water molecule. If this comes over here, that water molecule will attach to that. And in fact, I can get a lot of water molecules attaching to anything that's on the outside. So you can see that there's 3 water molecules attached to there. Here I could have water molecules attached as well. And actually, in real life, you can have multiple of those. So I could have 15 water molecules attached to my sodium or my chlorine. Now, this is very static, but what's going to happen in actual fact is these water molecules are vibrating and they have energy. And if they vibrate hard enough, eventually they will pull off a little ion, and then they will be surrounding it like this. And that ion will be floating then in the water. And this, because the water molecules have no charge, but the center is positive, this is a little positive blob that's floating around in the water. They will do the same thing to the chlorine. And so what will happen is, if I put sodium chloride into a glass of water, what I'm expecting is the sodium is going to get surrounded by water molecules, and so will the chlorine. I did that backwards. Sodium would be this way. The chlorine would be this way. And eventually those will get pulled apart. Now, that's one type of a solution. That's called an ionic solution. There's also solutions, and by the way, when that happens, this is why this will conduct electricity, because these now become a sodium completely surrounded by water. And so I have positive and negative blobs floating around inside of there. And that's all you need for electricity is positive and negative charges. Right? By the way, most of you know that if you heat the water up, you'll dissolve more salt. In other words, I can get more salt to dissolve in hot water than cold water. And that's because if the molecules are moving faster, the salt doesn't need, you don't need as many water molecules attached to pull it apart. And so you can actually end up with more salt dissolving in the same amount of water, and the reverse would be true as well. Now, the other type of solution that we're going to look at is a covalent solution. And a covalent solution would mean that we have a covalent molecule that is being dissolved. So what's going to happen is this. Not everything will dissolve in water. So for instance, if I take, where'd my water go? If I take this cup and I'll turn it down here, put some water in there, and I take a little bit of this, which is rubbing alcohol. Not going to use too much because this is valuable. That's a disinfectant. And mix those together. I get a complete dissolving. Now, you might say, well, this is going to be exactly what happens to the salt and the water. It's actually quite different. But if I was to take this water and I was to mix that with a little bit of vegetable oil, that vegetable oil, I don't know if you can see that well, that vegetable oil is going to sit on top. It is not going to dissolve. So there is a significant difference between this and actually this right here. So let me talk about covalent molecules. When we work with a covalent molecule or covalent solution, and I'm going to do this over here, we have two types of covalent molecules. A covalent solution is a covalent molecule in the covalent molecule in water. We have polar molecules and we have nonpolar. Okay, now here's what's going to happen. If I take a molecule, and say this is a polar molecule, it's actually not, but let's pretend that these ends are, say, charged, then water molecules can come up and attack this as well. But they're not going to pull it apart because it's a molecule. Rather, if this has positive and negative ends to it, it will attract to the positive and negative ends of the water. And as a result, it will disperse itself in the water. But if this is a nonpolar molecule, in other words, there's no positive and negative ends on this, the water molecules are not going to be attracted to them. The water molecules will be attracted to each other. And the water molecules then will cling together. Alcohol is a polar molecule. So when I poured the polar alcohol molecules in, alcohol molecules have a positive and a negative end. So does water. And basically, the water molecules will attach themselves to alcohol just as well as they will to other water molecules. But oil does not have a positive and negative end. So the water molecules are going to be attracted to themselves. I kind of think of this in terms of, if you went to a party and there was a group of people and they're all friendly, and you start, and you're a friendly person, then you're going to end up mixing together. Before long, everybody will kind of know each other. That's what's happening here. But if you have a group of people who are antisocial, they don't like anybody else, and then you have friendly people, eventually the friendly people will be gathered together and the non-friendly people will be off by themselves. That's what's happening here. The water will mix, these won't. Now what's interesting is if you take two non-polar liquids and mix them together, they will mix together. In fact, there's an expression that we will use called like dissolves like. In other words, polar molecules will dissolve polar molecules, or polar substances, I should say, will dissolve polar substances. And nonpolar dissolve nonpolar. By the way, salt is polar and water is polar, so that's why sodium chloride forms a solution. And that's, by the way, the reason that, say, if you have gasoline, which is nonpolar, it will dissolve oil, which is also nonpolar. So that's actually an important thing. And it's a little tricky to grab onto that, but just think in terms of, if I have things that have positive and negative ends, another one with positive and negative ends, there will be a connection. But if I have positive and negative ends and nothing over here, the water molecules which have positive and negative ends will join together. Okay. Now, what's really interesting about about this, I said there were two definitions of solute and solvent. With ionic compounds, every ion has to be pulled apart by a certain number of water molecules. And at some point, we run out of molecules. And it's very clear that the water is doing the dissolving. But if I take this one, which is alcohol and water, they're both polar molecules. Which one is doing the dissolving? And the answer is they are dissolving each other. In other words, alcohol dissolves the water and the water dissolves alcohol. So this definition doesn't work. I'm going to try something. I'm going to use a different color. Let's see if you can see that. Nope, a little hard. So here is the other definition. we say that the solute is the smaller part if this is covalent solution. And the solvent is the larger part for a covalent solution. So in this case, this was just a little bit of alcohol and a lot of water. The water is the the solvent. But if I had put mostly alcohol and a couple of drops of water in, then the alcohol would be the solvent and the water would be the solute. Now, one other thing that I need to mention in here, and that is, and we'll end with this, when we start talking about solutions, there's a constantly changing ratio. So that if I take and put a little bit more alcohol in there, I have the same alcohol-water mixture, but I don't have the same ratio. There's a way of looking at the ratio, and that is with an ionic substance. We talk about these terms, so we're going to use these. Well, actually, that's what the next section will be, is how we measure that. But there are two different, I'm not saying this very well. Let me just do it this way. We will have solutions which are unsaturated or saturated. Unsaturated means the solvent can dissolve more solute. Whereas saturated means the solvent cannot dissolve more solute. So if I went back to my salt water and I started pouring more salt in, eventually I reach a point where the salt will no longer dissolve. If I was to do that, then pour out a little bit of the water off the top, I would have a saturated saltwater solution. Right now, this is unsaturated because if I take and put a little bit more salt in, that salt will dissolve given enough time. When you're dealing with covalent solutions, something different is taking place. I literally can put a single drop of alcohol in here or an entire bottle and they will dissolve. And so we don't use the same words when we talk about that. What we talk about with covalent is whether it is, just a second, I want to see how your book, I believe it'll say it the same way. Should have had that done. Yeah, they don't actually use this term, but it's whether it is miscible or immiscible. Miscible means that it forms a solution, or they dissolve each other. And immiscible means that they do not dissolve each other. I actually like to think of this in terms of mixable and immiscible, but I just realized I should have done something here. With ionic compounds, we say that something is unsaturated or saturated. With covalent compounds, and actually with both, we are going to also talk about whether something is, I shouldn't say covalent, this is both. We're also going to talk about whether something is concentrated or dilute. And concentrated means that there is a lot of solute dissolved. And dilute roughly means that there's just a little solute is dissolved. And I'm getting pretty long here, so I am going to stop. What we are going to do, you're going to want to read through for me sections 14.1 and 2. And I would actually read the introduction as well. And then we're going to try problems 5 through 12 on the page at the end of the chapter, which would be 471. So this video went a little longer than I like them to, but there's actually quite a bit of information. It's not hard information. You can actually pick most of it up by reading in your book. So we'll end the video at that point.